Let's move on to topic B, decision trees and random forest. Decision trees are mostly used for classification tasks. They are a non-parametric form of supervised learning method. Decision trees work on the concept of finding out the target variable by learning simple decision rules from data. They can be used for both classification and regression tasks. The following are the advantages and disadvantages of using decision trees for classification. On the advantages side, decision trees are very simple to understand and can be visualized. They can handle both numeric and categorical data. The requirement for data cleaning in the case of decision trees is very low since it is able to handle missing data. It's a non-parametric machine learning algorithm that makes no assumption of space distribution and classifier structures. It is a white box model rather than a black box model like neural networks and is able to explain the logic of split using Boolean values. On the disadvantages side, on the other hand, decision trees tend to overfit data very easily, and pruning is required to prevent overfitting of the model. They are not suitable for imbalanced data, where we may have a decision tree that is biased. A decision tree would try to split the node based on the majority class and therefore doesn't generalize very well. The remedy is to balance your data before applying decision trees. Now let's go ahead and do an exercise to understand these concepts better. Implementing a decision tree algorithm over a dataset. In this exercise, we will use decision trees to build our model over the same Titanic dataset that we used in the previous exercise. Ensure that you use the same Jupyter notebook as the one used for the preceding exercise. First, we're going to import three GraphViz, string.io, image, export GraphViz, and py.plus libraries. Now, when I try to import the GraphViz, I get this error message. So that means I need to install the GraphViz library into my computer. I will use Anaconda prompt to do so. The command is pip install GraphViz. As you see, GraphViz is installed successfully. Now I will try to import these libraries one more time. Okay, apparently I also don't have py.plus. Let's install that one as well. Perfect. Let's see if I'm still missing anything. Looks good. Now I need to fit the decision tree classifier using the following code. Now let's plot the decision tree using a graph. In this plot, we will be using export GraphViz to visualize our decision tree. We will use the output of our decision tree classifier as our input CLF. The target variable will be the class names, that is died or survived. And we are going to get the graphic result as a separate window. Let's get this bigger. So what we have here is the output of the above snippet. This is a graphic visualization of the decision tree till a depth of 3. Now we would like to calculate the accuracy score using the following code. You should get an output of 77.3, which implies that our decision tree classifier scores an accuracy of around 77.3%. Hence, our classifier is able to predict 77.3% of the test data correctly. I hope you enjoyed this exercise. Let's turn back to our lesson 8. The decision tree is so called because the predictive model can be represented in a tree-like structure. A decision tree is read from the top down, starting at the root node. Each internal node represents a split based on the values of one of the inputs. The inputs can appear in any number of splits throughout the tree. Cases move down the branch that contains its input value. A case moves left if the inequality is true and right otherwise. The terminal nodes of the tree are called leaves. The leaves represent the predicted target. Decision trees use multiple algorithms to split at the root node or subnode. A decision tree goes through all of the futures and picks the future on which it can get the most homogeneous subnodes. For classification tasks, it decides the most homogeneous subnodes based on the information gained. This information can be calculated using either of these three algorithms: Gini impurity, entropy, and misclassification rate. In short, each of the nodes in a decision tree represents a future, each of the branches represent a decision rule, and each of the leaves represent an outcome. It is a flow-like structure. It gives details on how much information a future will hold about the class. Futures that are perfectly separable or partitioned will give us maximum information, while futures that are not perfectly separable or partitioned will give us less information. Here, Ig, the information gain, I, impurity, F, future, dp, parent dataset, d left, left child dataset, d right, right child dataset, np, total number of samples in the parent dataset, and left, number of samples in the left child dataset, and n right, number of samples in the right child dataset. The Gini index can be defined as the criteria that would minimize the probability of misclassification. The preceding equation is simplified Gini impurity formula for binary classification. Entropy can be defined as the criteria that maximizes mutual information. For a two-class problem, we can simplify the preceding equation as shown. This measures the classification error, which can be defined as shown. Gini impurity and entropy typically give the same results, and either of them can be used to calculate the impurity. To prune the tree, we can use the misclassification error. The random forest algorithm reduces variance overfitting by averaging multiple decision trees, which individually suffer from high variance. Random forest is an ensemble method of supervised machine learning. Ensemble methods combine predictions obtained from multiple Bayes estimators, classifiers, to improve the overall prediction robustness. Ensemble methods are divided into the following two types. Bagging. The data is randomly divided into several subsets, and the model is trained over each of these subsets. Several estimators are built independently from each other, and then the predictions are averaged together, which ultimately helps to reduce variance, which is overfitting. And the boosting. In the case of boosting, Bayes estimators are built sequentially, and each model build is very weak. The objective, therefore, is to build models in sequence where the latter models try to reduce the error from the previous model and thereby reduce bias, which is underfitting. The following diagram illustrates how the random forest algorithm works. The random forest algorithm works as follows. A random bootstrap sample, a sample drawn from the replacement, of size n is chosen from the training data. Decision trees are drawn on each instance of the bootstrap. D futures are chosen randomly without replacement. Each node is split using the D futures selected based on objective functions, which could be information gain. All these steps I mentioned are repeated k times. Each of the predictions by multiple trees are aggregated and assigned a class labeled by majority vote. The following are the advantages and disadvantages of a random forest algorithm. It does not suffer from overfitting, since we take the average of all the predictions. It can be used to get future importance. It can be used for both regression and classification tasks. It can be used for highly imbalanced datasets. It is able to handle missing data. On the other hand, it suffers from bias, although it reduces variances. It's mostly a black box model and is difficult to explain. I think that's enough for now. Let's go ahead and do an exercise to see this in code. A random forest model over a dataset. We will be using a random forest to build our model over the same Titanic dataset used previously. Ensure that you use the same Jupyter notebook as the one used for the preceding exercise. First, we're going to import the random forest classifier. And now we're going to fit the random forest classifier to the training data using the following code. Let's predict on the test data. And we should calculate the accuracy score. Well, you should get an output close to 0.79, which implies that random forest classifier scores an accuracy of around 79.1%. So far, we have implemented different classical algorithms such as support vector machine, decision tree, and random forest. We understood the mathematics behind these algorithms and the advantages and disadvantages of each of these algorithms. I hope these exercises helped you build your foundation to use these machine learning models in your own projects.